Hey everybody, so this is going to be a review of Newton's second law study guide for your Newton's second law assessment. So let's start off with going over this equation, F equals ma. So F equals your net force, m is your mass, and a is your acceleration. Remember, this can be written three different ways. It can be written as F equals ma, it can be written as a equals F over m, and it can also be written as m equals F over a. So make sure that you know how to use those different variations and make sure that you know what each of these variables stand for and also their units. All right, so number one, what would happen to the hockey puck in mechanical equilibrium after you apply another force to it? So let's just see this out, right? If we were to draw an FBD, so let's draw an FBD for this hockey puck. So originally, it's a mechanical equilibrium, so I'll just draw FBD1. But now, we apply this hockey puck with an additional force. So it's no longer in mechanical equilibrium. So this would be the force applied, that would be the normal force, and this would be the force of gravity. So as we can see, this is an unbalanced force situation. So this puck would actually accelerate. All right, so number two, we needed to highlight the correct answer. So acceleration depends on the blank force. So acceleration depends on your force applied, right? But is that the only type of force? No, right? We have to look at all of the forces that are acting on the object in order to identify your acceleration. So acceleration depends on your net force, or the sum of all of the forces acting on the object. So again, you can have all of these forces acting on the object. You can have friction force, you can have the applied force, you can have weight force, but what acceleration depends on is the net force, or the combination of all the forces acting on an object. So number three, to increase the acceleration of an object, you must blank the net force acting on it. So if you wanted to increase the acceleration of an object, you would need to increase the net force acting on it. So true or false, double the force on an object and its acceleration will double. Absolutely, it will double. And that is because acceleration and net force are directly proportional to one another. So if you increase one, you're going to increase the other. Or if you decrease one, you're going to decrease the other. So let's say that you doubled the force, so you expect a double in your acceleration. If you decreased your force, then you expect a decrease in your acceleration. So we say an object's acceleration is blank proportional to the net force acting on it. This is directly proportional. So again, that 1-to-1 ratio, if you increase one, you increase the other. If you decrease one, you decrease the other. So number six, for a constant force, an increase in the mass will result in a blank in the acceleration. So if we increased the mass of an object, this would actually decrease our acceleration. Again, if you have a more mass object, then that object has more inertia, which means it has more resistance to change its state of motion. So if it's an object at rest, it wants to stay at rest. So if you keep that constant force and then you apply an additional mass, you're going to see a decrease in your acceleration. So for a given force, the acceleration produced is blank proportional to the mass. This is inversely proportional. And that is just because if you increase your mass, if you increase your mass, you're going to see a decrease in your acceleration. If you decrease your mass, then you're going to see an increase in your acceleration. So you can see that the change is varied. All right, that's not that 1-to-1 ratio. It's actually that 1/1 ratio. So if your mass is 2 and you accelerate it, if your mass is 1 and you change that mass to 2 kilograms, then your acceleration is going to be 1/2, or half of what it originally was. Okay, so how much force is required to accelerate a 20 kilogram mass 5 meters per second squared? So for this one, we need to use F equals ma. So our mass is 20 kilograms, our acceleration is 5 meters per second squared. So we should get a force of 100 newtons there. So 20 times 5 is 100. And then what are the units for force? Newtons. So number 9, what is the mass of a car that exerts a force of 500 newtons and accelerates at 0.25 meters per second squared? So the car, we need to find the car's mass. So we are given a force and we are given the acceleration. So in order to write down your equation, you need to use Newton's second law, but rearrange that equation. So it should be m is equal to F over A, where F is 500 newtons and A is 0.25 meters per second squared. So your mass is going to be 2,000 kilograms. All right, so number 10, a dog pulls a 7-kilogram sled with a constant force of 14 newtons. What is the acceleration of the sled? So again, we have to use Newton's second law, but rearrange that equation in order to solve for acceleration. So the equation that you should use is equal to A equals the net force divided by your mass. So we have a force of 14 newtons and a mass of 7 kilograms. So you should take 14 newtons divided by 7 kilograms and get 2 meters per second squared. So Becky picks up her puppy with a force of 200 newtons. What is the acceleration of the puppy? Show all your knowns, so show your equation and show all your work. So Becky is picking up her 10-kilogram puppy. Okay, and it has a force of 200 newtons being applied upward on it. But what is also acting down on this puppy? It's the weight. Okay, so if we need to solve for the acceleration, we need to find the net force on this puppy. So let's go ahead and draw it out. So this is going to be our FBD for the puppy. All right, so Becky is picking up her puppy and she's applying a force of 200 newtons. So that would be like the force applied. All right, but what do we know is also acting on this puppy? The weight. All right, and to find weight, we take m times g. And the mass is equal to 10 kilograms. And g is equal to 10 meters per second squared. So in order to solve for the weight of this puppy, we need to take 10 kilograms times 10 meters per second squared, and the weight of this puppy is equal to 100 newtons. So we have 200 acting up, we have 100 acting down, so the net force, or the sum of the forces here, is equal to 200 minus 100 newtons, and we should get a net force of 100 newtons. But that is not what we are asked for. We are asked to solve for the acceleration. So let's use the information that we have already and solve for this acceleration. So we have the net force. We're given that the mass is 10 kilograms. So what is the acceleration that Becky is applying to this puppy? Or what is the acceleration of this puppy with the force that Becky is applying? So again, we use Newton's second law equation, but we rearrange it in order to solve for acceleration. So A is equal to the sum of the forces, or F net, over m. So let me just go ahead and write F net here, just in case you memorized that as F net. Again, they both mean the exact same thing. So your acceleration is equal to 100 newtons. Again, we just solved for it up here, divided by 10 kilograms. So if we had 100 divided by 10, we should get an acceleration of 10 meters per second squared in that upward direction, right? Because Becky is picking up that puppy. All right, let's move on to the next question. So highlight the correct answer. Friction always blanks the motion of an object. Friction always opposes the motion of the object. So if your motion is to the right, then the frictional force is going to be to the left. Define static friction and define sliding kinetic friction. So static friction is the friction that is on the object for an object at rest. So it's that initial breaking free friction. So you have to apply a certain amount of force in order to exceed the static friction. All right, so that is the friction that is holding something in place. It's preventing or opposing that motion. So define sliding or kinetic friction. Kinetic or sliding friction is the friction that is at play for an object that is moving on a surface. Okay, so it's an object that is moving along a surface. Two surfaces, the object's bottom surface and the surface of, let's say, the ground here, are applying a force together. All right, and we know that friction is caused by irregularities within the material and the amount of pressing force that is acting on the object. Okay, so as these two surfaces come together, they are going to result in a type of friction. This type is known as sliding or kinetic friction. It's for when something is in motion. So Post Malone is cruising on his private jet. The jet achieves a constant velocity when the total thrust of the engines on the jet are 25,500 newtons. How much air resistance acts on the jet if it is cruising at a constant velocity, and how do you know? All right, so let's draw a picture of this one. Let's draw a picture of what that free body diagram is going to look like. So the FBD for the plane. Okay, so we have the object here that represents the center of mass of our plane, and we know that the weight is going to act down. We haven't really talked about this before, but what keeps planes in the air is that lift. Okay, so the lift is going to be equal to the weight of the plane. It's what's keeping it in the air. So the sum of the forces are the F net in the y direction is going to be equal to 0. Now we want to look at the applied force and the frictional forces. And again, frictional forces within fluid, that would be air resistance. Because remember, a fluid can flow. So air can flow and water can flow, so they are both known as fluids. Okay, so then I will name this as the force applied. This can also be shown as FR for resistance. Okay, so we have an applied force of 25,500 newtons, and we are told that this plane is going at a constant velocity. Now, a constant velocity means that the object is not accelerating. So the acceleration of this object is equal to 0 meters per second squared. And if I wanted to solve for the force, I would say that, F is equal to ma. So F is equal to m times a, which is 0 meters per second here. So again, this is for my net force of the total system. Just wanted to make that clear. So F net is equal to 0. So the sum of all of your forces combined in the y direction and also in the x direction has to be equal to 0. In order for this to be at a constant velocity, in order for this plane not to be accelerating, so the acceleration equal to 0 meters per second. So, knowing this information, knowing that the lift is equal to the weight and that the force applied is acting to the right, and we need to get it equal to 0, what does this force of air resistance have to be? Well, your force of air resistance has to be equal to the force applied, or 25,500 newtons. All right, let's keep moving forward here. So draw an FBD for the following scenario. A horse is pulling a sled and is causing the sled to accelerate forward to the right. Identify all the forces acting on the sled and draw an FBD. So we have a sled. Sorry, that's not a very good sled, but it's fine. We're going to live with it. And this is my horse drawing the sled. Okay. So again, the object that we want to focus on is this sled. So let's identify all of the forces that are acting on the sled. So again, the sled can be represented by the center of mass of the dot. So we have the weight, we have the support force, we have the force applied from the horse, and then we have this frictional force. Okay, so another thing that we are given in this problem is that it's at a constant velocity. Oh, sorry, it's accelerating forward. So the force applied has to be greater than the frictional force.